Industrial IoT is about generating value by extracting insights from your industrial assets and their environments. But to do that, you need the right tool to normalize and to contextualize the data so you can implement analytics and so on after that. There is a very good tool called HighByte that allows you to normalize and contextualize your data in a very simple and intuitive way. We have John Harrington from HighByte today on the IoT Show to discuss Industrial DataOps. Hi everyone, this is the IoT Show. Thanks for tuning in. I'm Olivier, your host. Today with John, we will talk about Industrial DataOps. John, how are you?
I'm great. How are you, Olivier?
I'm fantastic. Great. Enjoying, living the dream. And I think it's my dream. So I think it's a good thing, right?
It's a great dream.
What about you? So, John, first, before we get into the details, and, we'll continue the chat part here, but who is John Harrington? What are you doing in life? Where are you?
Where am I? Well, I live in Portland, Maine, in the U.S., for those of people watching who may be international, but Portland is about 2 hours north of Boston, so we're on the East Coast. I am the Chief Product Officer at HighByte, and I think we'll get into a lot of details on that. My entire career has been around delivering solutions that optimize manufacturing companies and working with manufacturing companies, and I spent some time working within them and some time working outside of them. And about 5 years ago, 5.5 years ago now, I co-founded HighByte with some other former colleagues, and we're really excited about where we've come. We've got, the company is growing, the customer base is growing tremendously, and it's really exciting times.
It is. And interestingly, well, you just mentioned that you have an industrial experience. You've been delivering solutions to customers for some time already. And, I've been talking on the show and blogs and so on about the fact that in my view, the industry of industrial automation, manufacturing, industrial IoT as an additional one are going towards a model that is about integrating pieces of technologies rather than building an end-to-end solution on your own or buying a SaaS do-it-all solution out there. So it's more about integrating functional pieces that work for you and that are specialized in an area. And the one that we want to talk about with you today is Industrial DataOps. I don't know if it's just a buzzword. We have DevOps, we have infosec, DevOps, whatever, ops something. But Industrial DataOps is something that you guys came up, not maybe you didn't invent the term, but you're implementing an actual solution about it. So how did you come to that beyond, having real life experience with customers? How did you come to the concept of, hey, we need to really have a solution that works really well for that part? Tell me more about that.
Yeah, I know. It's a great question. So when we started HighByte, this is 2018, and if you remember back to 2018, big data was important. Was what a lot of people were talking about. IoT platforms, analytics, and everyone wants to digitally transform. Companies need to digitally transform. What we found is, and people are starting to talk about, this is really hard and companies aren't able to scale. And, at some level, we're still seeing that today, that they're able to identify great projects to implement. But the technique that they use to do a proof of concept is very different than how you would then scale that out across maybe 100 or 500 machines within a site, and then how you would scale it across 20 sites. And so there are very different challenges there when you move from using an Arduino or Node-RED to try and collect some data and move it around and bring it into, an analytic or a dashboard, than when you're trying to scale that across your enterprise. And that's where people have gotten hung up. And so, we realized that connectivity wasn't the problem. It was the curation of data for the target systems and for the target use cases, because what's happened is now there are hundreds of use cases, and there are lots and lots of there's nearly infinite data out there, but we need to curate the data for those use cases for the consumers in order to deliver it to them. And so that's where we've really seen the industry start to move towards. That's what, in my eyes, data ops is really focused on. It's on the delivery of data, but also the curation of data for the target, because we're talking a lot about data. Maybe I should take a step back. We really focus in industrial companies. Yeah. And those companies have a lot of industrial automation and a lot of systems in and around the factory floor to collect information so that they can optimize. And sometimes we're optimizing on R&D, sometimes we're optimizing on quality, sometimes we're optimizing on the process. In the past, it was all about process optimization, but now we're really trying to drive these other use cases. Now we're optimizing on sustainability and environmental impact. And so how do we do that effectively, again, across the company and across the enterprise? So that's really where the challenge came from, and rethinking how we integrate systems. Because as you said, we've always been able to kind of wire things together. I'll use wiring as an analogy, but at scale now with technology the way it is, we can really plug and play things, and that's really exciting. That's really when things, from our perspective, go to the next level.
Yeah, I agree. But now comes the problem of, the people who need to deal with that data that is like coming from all these different types of sources. They are not data experts. They're not data scientists. They're not IT people. They know that they want to extract insights, and they actually know how to extract value from that data, but they need tools to contextualize, normalize, like to deal with the data for them so that they don't have to try and reinvent the wheel there. And that's exactly what HighByte is about, right?
Exactly. Yeah. And what it comes down to is the people that know the data are different than the people that are using the data. Mm-hmm. And when you have that sort of situation where the people that run we call them OT in industry, right? We call them operations technology. They're often made up of controls engineers and automation engineers and chemical engineers and lots of other engineers who are focused on operating the factory. Those people know the data. They know all those source systems. And so we call them the domain experts. Mm-hmm. The challenge is that the consumers of the data, it used to be that it was just them. They would consume the data, they would optimize. Now the consumers are outside of that. Now the consumers, like you say, maybe data scientists, maybe data engineers, maybe quality engineers who, in large manufacturing, quality is a very different department than operations. R&D is a different department. Sustainability is a different department. So it's these different departments that aren't familiar with the factory floor as much, but they'd love to get access to that data. Now, in the past, they would get a report a week, and it had very little actionable information. But now there's so much information available for them that if we could give it to them and they could understand it, then think about how manufacturing could just take another step change. And that's really, in my eyes, what digital transformation is all about.
Yeah, well, let's see it, because seeing is always better.
Let me show you.
So let's see if HighByte talks to people who have to deal with that data. Like, run us through a demo here.
All right. So what we're looking at here is what we call our UNS client, or Unified Namespace Client. And what you can see here is that I've got this structure. And here, if I click on my motor, you can see a payload of information that's over here on the right. Now, this is a data set that would be really helpful for an asset maintenance person who's trying to determine, is this motor failing, or are there any issues with this motor? Or there are things that we should do with this motor? They would use this data, monitor this data, see how it's being impacted. Um, but what we've got here is all this data is organized. So not only is it just random data points, but I've created this one collection of data into a payload, we call it. And if I select through here, I can see different machines and their data sets as well. And in fact, I can even see like some metrics. So you can imagine some of this data may be used by the maintenance team, some of the data by the operations team, some of the data by the management team, or to drive some dashboards, maybe some dashboards on the factory floor that show how are we doing, what's the status of the line, are there any issues, are there any alerts? So
Yep.
really rich information is available.
Totally.
But
And
what's key is that we pull this all together.
yeah, and as we're saying, John, like it's already pulled together for you're looking at it from the perspective of that operator who knows his business, knows that he's looking for this kind of information here and there, and just wants to use it. Right? They don't want to mess up with all the rest. There's two aspects here, and you'll dig into that, which is how did the data come here, and what is that thing called UNS? I know what it is, but can you tell me a little bit about unified namespaces?
So to break down the term UNS, unified and namespace, and it's not that crazy a term. In actual fact, a namespace is the structure of data within a system. So a namespace of a SQL database would be the table structure and all the columns in them. That would be the namespace. However, what we're trying to do is, as we try to pull the data out of the industrial space and we move it into these people who have less understanding of the factory floor, we need to organize the data for them. And so that's where we call it a unified namespace, where we follow some key standards. For instance, the ISA 95 specification, I think it's section 2, talks about organizing information based on company, site, area, line, zone sometimes, depending on the manufacturing plant. Many times you have cells, and then even down to an asset. And the idea is that if you could put the data in that structure, then anyone can come in and understand that structure. Now, if I want to look at the productivity of the line, then I want to look at those metrics on the line. Mm-hmm. If I want to do asset maintenance, I wouldn't look at the line. I would dig all the way down to the asset that I want to look at, and I would pull that information. And we're using a technology set called MQTT and an MQTT broker where we can publish the data in, and then consumers, users of the data can subscribe to that and then bring it into their own systems and work with that data. So it makes it very accessible to many people within the corporation and to many systems within the corporation.
Interesting. Yeah, interesting. So you basically are normalizing in a way the way
Exactly.
It's not you, it's actually the industry is normalizing how data should be presented to systems. Yeah. The source of data is, anything. It's devices behind a CAN bus, BACnet, Modbus, whatever, OPC UA. But here you are setting things in a way that you have models, and you set the data in these models so that they are now explicit for systems like cloud solutions and other ones, right?
Yes.
Awesome.
And like you said, as you move from one machine to the next, we can standardize that data set. So if they're similar machines, even if they're very different, you could even standardize from one site to the next the set of data that you want for, say, injection molding machines, or for asset maintenance of motors, or for metrics on a line. You can standardize that data set and then roll it out across each company or each site and each application, but you don't have to change the source data. And that's really the beauty of a solution like this, is that by abstracting the normalization and standardization outside of those source systems, you can leave those in place to execute the business while we have a way of standardizing the data as it lands in the cloud or as it lands in whatever system needs it.
That makes sense. So we're talking about data here, but for people to understand, especially for the audience of the IoT show, to understand a bit better, what we're looking at right now, this UI, the HighByte UI that you're showing right now, is actually running on the edge, or is it running in the cloud? Where is it running?
That's a great question. So it can and typically runs on premise.
Okay.
So I would call that the edge, though, depending on who you're talking to, people have different views of what the edge is. But yeah, we recommend to our customers run our software as close to the data sources as possible.
Okay.
And the reason is we're going to be communicating more with those source systems because we have lots of optimizations for when we're publishing the data out. So there's just network load and load on the, inherently on the systems. There's also security and efficiency. As once we get that data, we can guarantee that it lands where it needs to go, whether it's going to a UNS, whether it's going to AWS or Microsoft or Snowflake or whatnot.
Got it.
So we can really ensure that it lands, and we can optimize on that. We can buffer it. We can do lots of different things to just optimize on the communications there, depending on what the needs are.
Yep. So to simplify things, I would say, HighByte would be running on a powerful gateway at the edge, right? Something that you connect different field buses to access devices or assets data. And then on the other side of things, in a secure way, you would have this gateway connected to a cloud. And it comes, I would assume it comes as a container or as a running on a VM.
Either way, we can deploy on Windows, on Linux VMs or base hardware, or we can deploy as a container. Yeah, and that's the trend that we're seeing. Everyone is moving towards how do we deploy these things at scale, especially across sites. Mm-hmm. How do we manage kind of that working with the DevOps process of the IT team, but be able to deploy and run and be usable and configurable by the OT team.
That makes sense. Okay, so that clarifies where things running, what they are physically or close to physically. They're at the edge. We're connecting these sources. Now you started from the end almost of the story, which is great. I want you to rewind and tell me, how did you get to where you are at on that screen, which is data that is already organized? Show us some of the steps.
No, it's a great question. I started at the end because we always ask our customers and our prospects to start at the end. You need to understand how you're using the data to define and where it's going to define how it needs to be structured in order to satisfy that use case. So we always say, start with the use case. Are we solving for predictive maintenance? Are we solving for quality, for production metrics? And then work your way back. So here you can see a data set, or here's a motor data set. Let's work our way back and see how that happens. I'm going to start off in models, and I'm going to go into my motor definition of a model. So think of a model as just a set of data. It's that data set that I was showing, but it's just that standard structure that every time I want to collect data on this motor for asset maintenance, this is the set of information that I want. So that's kind of defining the structure. Then we go in and we say, okay, how do we source that structure? How do we source that data? Not the structure, but the data. And that usually starts with making connections to systems. So I'll come in here and maybe I have a connection to my OPC UA system. And here I'm connecting, and you define how you connect to that system, and then you define inputs. And of course, with OPC, we're able to easily come in and we can browse and we can find different, different tags, and we can bring them in. But ultimately, I build up this list of data points that I want to work with. Now, what's important is a lot of times contextualizing information requires data from other systems. So for instance, if you're collecting data on a motor for predictive maintenance, you may also want to know information about the vendor of that motor. Because when you're doing some queries and you're looking across, if all this data is going into your data lake and you want to say, I want to pull all of my Parker motors and I want to, of this model, and I want to do some comparisons or use the same AI or the same machine learning for all of them. So it's important to contextualize data. So not only do you want your telemetry information, but you may also want connections to a database. So here I've got connections to a database. And if I just take a look at this query, you have to build this query out, but we give you a lot of tools for doing that. You can see the structure of the database. You can just drag and drop into this query builder. And then once you've once you've defined that, you can pull up the data set and take a look at it. So it's a very low code to no code environment where a lot of it is just configuring what data I need to get access to from different connections so that I can piece that together into that model, right?
Got it. Got it. So let me ask you before you move on. So you just say that you're doing everything in the UI, low code, no code, but it triggers the question. Here you're doing that on one individual gateway or HighByte instance.
Yes.
How do you scale? How do you go in infrastructure in real life? You have several sites. You're going to have one of these or different, many of these instances running here and there. And you might have configuration that you want to replicate. Do you have a notion of templatization and deploying of templatized versions of the instances?
Yeah, so this entire configuration, when you have it set up in a multi-hub environment, you can define a master hub. You can compare configuration across different hubs, and you can synchronize across different hubs.
Oh, nice.
So you can move configuration from one hub to another hub as it moves, say, from development to test to production.
I like that.
Very easily. And you can even define exactly what you want to move. But let's say that, well, in some cases, we have hubs that are separated by firewalls, and some companies don't really want to do that. They want to do infrastructure as a service, and they want to do a much more programmatic way using their DevOps processes. We also have the ability to export any components of the system. So here I'm just logged in. I can select any models that I want. And I can also come back, maybe one of these connections as well. And then I can say, let's export these. And it creates a payload, and I can save that. And then I can put that into my DevOps process, run it through the approvals, manage the versions and that kind of thing. And then the production can be completely hands-off because you can just push that over, either manually import it, or you can push it across an API. So we've really tried to optimize on what are the modern day IT processes and systems that they like to deal with, and how do we work in with those? So really focused on that DevOps process, on containerization, on monitoring of logs, that kind of thing, to really work with them, because a lot of it is when you scale, you really need to work with all those systems.
Nice. I like that. And sorry if I jumped the train or whatnot there, but I really I'm curious into this kind of how do you go to scale? How do you go to real life solution? So keep going. I mean, I think there's even more interesting things to discover.
Yeah.
We'll not discover everything, but what are the main pillars here of HighByte you want to highlight?
There's a couple of things left to get this data moving. The next thing I'll talk about is an instance, which is essentially taking those connection inputs, and then you map these to an instance. Mm-hmm. Now, this looks kind of complex. This is that model definition you recall that I had defined. Yep. But the way that you map these in, over here on the right-hand side, we have our reference browser. I can select my OPC connection, and if I filter on motors, all I do is drag and drop these in. So it's although it looks a little complex with these curly brackets and whatnot, that's so that you can go in and make changes, but you're literally just dragging and dropping components in. And I showed you how I can do that with my OPC UA. I can also do that with SQL. Let me find my motor CMMS system. Let's come in here. We've got that query. I can open that up, and I can see all those data points that came back from that SQL query. And again, these were just drag and dropped into our system. So I could pull in the ID, or I could pull in whatever information that I need to build out this data set. So now I've got all the information in here. If I come up, I can do a quick test read. Let me reset and do a quick test read. If I pop that up, you've got that data set now. So now we're pulling in data. In fact, in this one, I'm pulling in from a REST API as well. So I've got some OPC data. I've got some SQL information. I've got some REST information all put together in a single payload. And I've got some contextual information around the site, the area, the line that I just manually typed in. And then we take this data and we send it out by using a flow. So the flow really defines that motor. And here I've got two motors. And I want to send it to my MQTT structure, to my MQTT broker. But I want to use the asset definition, which allows us to pick information out of that payload and put it in and align it into our unified namespace client. So let me pop that up again. And here, this is what we were looking at the beginning, where we've got our motor and we've got that data set coming in. It's really identical to the definitions that we just did in the flow and in the instance. Nice. So the flow is where we give it motion. And here I'm sending it out once a second. This could be sent out, it could be sent out once every 10 minutes or whatever we need to do there.
Nice. And so this flow that you just described is kind of a like filter and path through. Do you have more advanced analytics you can implement on that data flow?
Yeah, that's a great point. We've got the concept of pipelines. So in many cases, people just want to move the data to a target and they'll just stream it out, and that works very well. But in some cases, we need to take a much more curated approach to either requesting information, to transforming information, or to delivering information. And that's what we call pipelines. So here, I'll just show you a real simple pipeline where we take our motor information and then we break it down into individual payloads. Because sometimes in MQTT, we really want the data to be individual values that you can subscribe to. And so this is an example of a simple payload, a simple pipeline where we just take the information in, we process it, we flatten it, we break it up, and then we send it to our target. And in this case, if I just jump back into my flow, I can add that pipeline. I can show you exactly what that looks like. Now, if we jump into our UNS, we now have, instead of that one payload, which some people like, we now can subscribe to individual values. So these individual values, maybe someone wants to just get access to individual components, we can do that. So pipelines allows us to sequentially define the different steps. In some cases, we may be breaking it down like I just showed. In other cases, we may be buffering it to send it to the cloud. Like if we want to send it to a data lake, we may want to collect the data for maybe 100 records and then write them into a file, compress that file, and then deliver that to the cloud. So lots of optimizations there. And pipelines really gives us that sequential approach to transforming data. And again, really easy to just drag and drop, interface, define each component, and it'll sequentially walk through that. And of course, it's probably important that I link those up. Yeah. So,
and do you have, John, already available or in the plans the notion of offering customers the ability to add their own processing, modules in there? Because like you have a collection of them here, but can they program their own ones? Can they use existing third-party, AI models or something that will allow them to do advanced analytics at the edge by just drag and dropping and importing models out?
So we do have the transform function that allows you to run complete JavaScript in whatever you need to do. Now, that gets you partway there, so we can transform that data. You can also import third-party libraries. So if you've got some analytic or you've got some type of application or transformation that you need to make, you can store that. That could have been written by someone else. You can import that and bring that in and leverage that. We don't consider ourselves an analytic platform, more a data curation and contextualization platform. We interact with a lot of analytics, and a lot of times the person that wrote the analytics application either wants to consume a file because it's a lot of history or a database, or they have a REST API. So that's another easy way that we would interact. We could just have an output that sends it to a REST API on their side, and then the analytic would be running. So it's really easy to link up. We've got some out of the box connectors like OPC and SQL and Pi Historian and a number of the cloud services like S3 and Azure Blob and Snowflake. Mm-hmm. But we also have open standards like MQTT and REST, and we can write to CSV files and Parquet files. So it makes it really flexible in the way that we would interact with other applications.
I like that. And it comes back to the point I was making of choosing and integrating pieces of software together that do what they do really well. And I kind of actually was asking the question because I've been recently playing around with like things like Litmus or Cubitron, and they have an approach that is similar but not exactly the same because they're focusing on some aspects and some use cases. You're focusing on other ones, and so I like this notion of curating the data. And you mentioned also that most often your customers don't really want to do edge analytics. They want to clean up the data so that they can send it somewhere else for the analytics to happen somewhere else, which is perfectly fine, and in many cases, the right thing to do, for sure.
Yeah, we see there, this has become an ecosystem. It's not a one player wins everything type of environment. And so we've really optimized on the curation and delivery of data. Instead of being kind of that full stack approach of, well, we'll get the data and then we'll have a presentation layer and we'll have an analytic layer. The problem is, that worked well when you had a small number of people that needed that data and they could all use that same system. And, that's kind of the SCADA days, right? But now what we're seeing is such a wide range of people, and a lot of them have their own systems and tools. And if they don't, a lot of people are utilizing the cloud, which has a lot of very powerful systems and tools for collecting and analyzing data. So we've really doubled down on making it very easy to deliver the data wherever it needs to be, wherever the consumer is, and however they need it. And really building that data ops discipline of being, thinking about your data strategically and delivering it across the enterprise.
I like that. I like that a lot. I think you're saying it really well. And as a matter of fact, my next question was, John, what do you recommend someone who wants to learn more about industrial data ops in general and about HighByte, which is a great solution that will help you in that endeavor of doing industrial data ops? So, what is your recommendation right now?
Yeah. So we have our website, and the website has lots of information. In fact, I pulled up some information earlier. We have this guides page. It's available off of the resource guides. And then in that, we've got two key pieces of information. One is this data engineering workbook, and it really walks you through how to get started and how to think about these sort of systems. The other one is this data modeling guidebook. And then there's also some white papers and just lots of information on our website. I recommend people check that out. We also have a YouTube channel that's got over 80 videos, so people can also check that out and see the software, see it work, see how they could interact with it. So that's really powerful as well.
Awesome, John. Well, we'll add the link in the description down there to the site.
Great.
Thanks a lot for your time today. I hope that you'll come back to the IoT Show someday with even more content and interesting discussions around data ops. And everyone, thanks for tuning in. Thanks for watching the IoT Show. Talk to you soon.
Thank you, Olivier. It was great to talk with you, and thank you for inviting me to the show.
Of course. Bye.